So we're going to use the compound angle formula now to solve this expression. Now you can see here it tells you that 5 pi on 12 is equal to pi on 6 plus pi on 4. So they've split this fraction up into two pieces. Okay, it's kind of backwards of what you do if you have two fractions that have different denominators. So you can see that both of these are different. We times the top and the bottom here by 2 to get 12 underneath. We times the top and the bottom here by 3 to get 12 underneath. So we'd have 2 pi on 12 plus 3 pi on 12 equals 5 pi on 12. That's where we're getting this expression from. Now, just out of interest, if you're actually given an expression that you can't work with, it's a non-standard angle, so pi on 12 is not a standard angle, what you can do to figure out what pair of angles you could work with is to write down what you're working with and think about two different angles over 12. Okay. Now you want these to be able to cancel down into standard angles, so something over 3, something over pi over 3, something over 6, something over 4, something over 2. That's what you'd like. So ideally here with 5, we know that 5 can be made up of 3 plus 2, it can be made up of 4 plus 1, it can be made up of, that's it really, 5 plus 0, but that's not helpful. So what we're going to do is actually let's look at those two cases. So let's look at 3 and 2. So 3 pi plus 2 pi, that would be 5 pi. Let's think about how these simplify down. So if we divide the top and the bottom here by 3, this is going to be pi on 4, plus divide the top and the bottom here by 2, and you're going to get pi on 6. So that's what you've actually been given. That's where it comes from. You could try also with this 4 and 1. But what you'll find with 4 and 1, if we'd done that, and I'll do this over here, you might have 4 pi on 12 plus 1 pi on 12. That gives you the 5 pi on 12 that you need. This is not a standard angle. This is, divide the top and the bottom by 4, but this is not. So this is not helpful to us. So that's where these come from. So often in questions you won't actually be given those to start with. But let's work with the first question. So our first question A, we're going to look at evaluating. And it's sine, and you can also see here that we're going to be looking at sine of two angles added together. So sine of 5 pi on 12 equals sine of pi on 6 plus pi on 4. We're going to use our compound angle formula. I'm just going to write CAF here for compound angle formula. Now for sine, remember that sine of x plus y is the one that has the sine x cos y. Remember it happens in the different pairs, sine and cos together, and then cos x sine y. And the nice thing with sine is that it's a plus in the middle. Okay, whatever that sign is there is the sign that goes there, it's the same. So what we're going to do is actually use that information now to help us solve. So we've got here, it's a good idea to write down what x is. It doesn't matter which one is which here, I'm just going to use the first one as x, and I'll write down the second one as y. So that means that for us, sine of pi on 6 plus pi on 4 equals, and we're going to have sine x, so sine of pi on 6, cos of y, which is pi on 4. That's why it's a good idea to write them there, so you can actually see quickly cos of x, x is right there. So you don't get confused. I find if you don't write them down, you can get confused sometimes with what goes where. So at this point, we're going to use our magic triangle, which is the classic one. So pi on 3, pi on 6, root 3 on 2, or your equivalent, it doesn't matter. So sine of pi on 6 is a half, cos of pi on 4 is the boring 45-degree triangle where each of the sides is root 2 over 2. So for that one, I'll put that there too. We know that this is times root 2 over 2. Think about the quadrants too. In the unit circle, pi on 6 is positive for sine, pi on 4 is positive for cos. Cos of pi on 6, cos is root 3, adjacent over hypotenuse. And sine of pi on 4, that will be positive as well, and it's root 2 on 2. Now it's a good idea here to actually factor out things that are common. I'll just do the multiplying first. Multiplying with fractions, always remember tops and bottoms together. Root 2 on 2 times 2, which is 4. On the top here, we're going to have root 6. Surds multiply inside the square root. 2 times 2 is 4. take out what's common. So in this case, you're actually going to find here that you've got a quarter that will come out the front. So you'll have root 2 plus root 6. Okay, like that. Now you could leave it like that. The other way that you may write it as well is to identify here that root 2 is common to both. So you could actually take this root 2 out the front and have 1 left over and that root 3 left over as well. So therefore, it's a good idea just at the end to write down what it was that you were doing, which was finding sine of 5 pi and 12, and what your answer was. So in factorised form, our answer is root 2 on 4. Okay, so again, for the next one, you could pause at this point and try and solve this one without the video and then just skip to the end. See if you were right. Again, with pi on 12, the hint for splitting this into fractions, something over 12. Now we're trying to find 1 here, so things that could possibly work would be like 4 take away 3 or 6 take away 5. You want something that will split up. 5 won't work because you'll end up with 5 over 12. So let's try 4 pi take away 3 pi over 12. That will give us 1 pi on the top over 12. Cancelling, top and the bottom, dividing by 4, you get pi on 3. Take away, dividing the top and bottom by 3, pi on 4. Cool, which is what they have. So we're going to use that now to help us solve this next expression. So this time we're looking at cosine, and we're going to be using the cosine formula, compound angle formula. And for cosine, remember that the cosine angle formula is a little bit different. So we're looking for cos of pi on 12, which is equal to the cosine of pi on 3 minus pi on 4. Now we're going to use compound angle formula, which is cos of x take away y equals, with cos, it's always the same angles together, the same trig together. So cos and cos together, sine and sine together, and the sine is always just opposite to the sign that's in there, so it's a plus. So that's the formula we're going to use, and what we need to do now is just plug in our values. So let me just erase this section. All right. So we've got let x equal, let x be the first one. It's very important here in the ordering, that has to be the one that's before the negative sign. So x has to be pi on 3. And let y equal pi on 4. So now we've got cos of x take away y, x is pi on 3, y is pi on 4, equals cos of x, cos of pi on 3, cos of y, so we know what y is, plus sine of x, which is pi on 3, and sine of y, which is pi on 4. Again, what we're going to do is use our triangles over here. So cos of pi on 3, that's a half, times root 2 on 2. Remember, think about your unit circle. Everything here is positive. They're all in the first quadrant, so they're all positive for sine and cos. Sine of pi on 3 is just the opposite. Okay, and with this again, what you're going to notice is that this is going to give you exactly the same answer as we got for sine of 5 pi on 12, because with simplifying, you're going to have root 2 on 4 plus root 2 times root 3 on 4, and the common factors that we put out the front, we've got 1 plus root 3. So that's actually the same working that we had and the same answer that we had for part A. So those are really about using your compound angle formulas. Make sure you write down what x and y is so you don't get confused. Write out your steps and then simplifying your answer at the end.